Okay, so to wrap all this up, the last thing to do really is just to explain to you where does this mv squared over r comes from. Really, it's a bit of a cheat because I'm really going to explain the centripetal acceleration is v squared over r, and of course, mv squared over r is really just from Newton's second law. Is that out of the glare? Yeah, just about. Okay, so we do need a little bit of calculus because things are now going in circles. So we need to see how we can do calculus with things around an angle, right? So in particular, we need to introduce two concepts, and that's very, very simple. And even if I don't introduce it now, you will need this in 3C. Okay, so in my philosophy is usually the earlier you see something, the better, because learning is basically just seeing something repeatedly over and over again. So the more you see it, the better. So it's better to see it right now, and it's very simple. All you need to know is how to take derivative of sine x. If you take a derivative of sine x, it gives you cosine x. And if you take a derivative of cosine x, it gives you minus sine x. It doesn't go back, but sine goes to cosine, cosine goes to minus sine. This is the thing you want to remember. Okay. Yeah. Now, a small variation of it is if I take, so of course, the proper way, first of all, the proper way of writing this is d dx of sine x. So you read it as differentiate. So the way you read this symbol is differentiate sine x with respect to x, or differentiate with respect to x sine x equals to cosine x. And differentiate, you can put it on top if you like, differentiate cosine x with respect to x equals to minus sine x. Okay, so that's the proper way to write it. But a small variation is, what if I have sine some constant times x? If I have a constant times x, if I differentiate that, all you need to do is pull the constant out first, and then rewrite what is the derivative of sine. So that would be cosine and copy exactly what's inside. So another way to think about it, right? It's to differentiate that, you just ignore the fact that it's kx. So if it's sine 2x, if you differentiate that, first write cosine 2x, and then whatever constant in front of x, you pull it out and put it in front. That's it, okay? Beware, this does not apply to x squared. If you have 2x squared, the general rule is this is slightly even further beyond this. What really is going on is you first copy whatever's inside, so it's cosine 2x squared like this, and you differentiate this and put it in front. Okay, it's called the chain rule. So you do them in chain. So you first take sine whatever, right? Differentiate the sine, gives you cosine of whatever that is inside. And then as a chain, you differentiate whatever's inside here. So that gives you 4x like this. So you differentiate 2x squared, which gives you 4x. That's the result. So here, it's basically in special case of a chain rule. You differentiate sine 2x, you get cosine 2x, and you differentiate whatever's inside and put it in front. Okay. So yeah, same thing. If you differentiate cosine kx, and if you differentiate that, you will get minus sine of kx and pull out the k, because that is the derivative of that. Okay, so this is a small variation of it. So the chain rule variation. Yeah. And that's all you need to know to analyze this.